Hey everybody, welcome back to another math lesson. Today we're going to be moving on to lesson 3 of our exponential and logarithmic functions unit. And we're going to be talking about and introducing what logarithms are. Alright, so let's get started. For the exponential function y is equal to a to the power of x, the inverse of that is going to be, you're swapping your x's and y's, it's going to be x is equal to a to the power of y. Okay, so for an exponential function, the inverse will be this. This inverse is also a function, and it is called a logarithmic function. Okay, so that's basically what the inverse is. So you have your exponential function, and the inverse of that is your logarithmic function. So in order to isolate y, it is written as y is equal to log base a of x, which is read as log is equal to log of x in base a, or log to the base of a of x equals the exponent, where a is a positive number other than 1. Okay, so the following is the same thing, just said in a different way. All right, so we have the log of a of x, where a is your base, x is your argument, and y is your exponent. Okay. Whereas your exponential form, you have x is equal to a to the power of y, where a is your base, x is the solution, and y is the exponent. Okay? So again, it's the same thing, but it's just said in a different way. Okay, so if you're saying x is the argument, that's basically what the solution is, okay? For your logarithmic form, because in your exponential form, you can see that x equals a to the power of y. You can see that x is the solution in this case. All right, so a common logarithm is a log with a base of 10, and it allows us to use the log button on our calculator. So steps to convert from exponential to logarithmic: you place the base of the exponent as the base of the log. The number beside the base comes from switching sides in the equation, and it always equals the exponent. Think of the rule of 7, all right? Okay, so let's try an example. Example 1. Express the following exponential functions in logarithmic form. So we have 2 to the power of 3 is equal to 8. That means, okay, if we're going to swap everything around, okay, where the base, place the base of the exponent as the base of the log. Which means we're going to have to make this so that it's 2 to the power of 3 is equal to 8. That's going to be log of 2. So that's the base. Okay, then your solution is now your argument is equal to 3. That means that, again, it's the inverse, right? So that's saying that 8 is equal to 2 to the power of 3. Whereas this one, we have 3 to the power of negative 2 is equal to 1 over 9. That's saying that log of 3 of 1/9 is equal to negative 2. So basically, we're going to zoom out just for a second. Your 2, so your base will go here. Okay, and then you have your exponent is going to go on the outside. Okay, so it'll essentially will equal that. And then finally, your argument or your solution will go here. Okay, so that's how you would split up. That's how you express an exponential function as in logarithmic form. If you were to look at this, so it says the rule of 7. It kind of makes a 7, and it looks like this. So it kind of makes a 7 a bit, right? Where log base 2, so you go across. Right, so you go, I'll rewrite it here. So you're gonna go across, you start, your 2 starts first, then you write your 8, and then you finish with your 3. That's how you would split. That's the order of the numbers that go when you're writing a log. Other way, right? So express the following in exponential form. Okay, so it's gonna be the same thing where it says the rule of 7. So you're gonna start with the 4, then write the 2, which gives you the answer 16. So it should be 4 to the power of 2, which equals 16, okay? So the next one's gonna be log base 10, right? When there's no number written there, that's saying log base 10. So it's gonna be 10 to the power of negative 3 is equal to 1 over 1,000. Again, if you wanna use the rule of 7, your 10's written first, then your negative 3, then your 1,000, or 1 over 1,000, okay? C. We have y is equal to a log of half is equal, or log of a half of 4. So again, it's going to be a half the power of y is equal to 4. And finally, the last one, m is equal to log b of n. So that's going to be b to the power of m equals n. Okay? So moving on, to evaluate logarithmic functions, we can try to use the following rule. So we have log base b of b of n is equal to n. This means we can determine the logarithm of each number if the number can be rewritten as the power of the base to the logarithm. So steps to evaluating logarithmic functions, you rewrite the argument in terms of the base. When the base of the log and the base of the argument are equal, the solution becomes the exponent on the argument. Or change the exponential, make the bases the same, and equate the exponents and solve. Okay, so it's kind of similar to how we solved exponential functions in the last lesson. Okay, so that's essentially how you would solve. You want everything to be the same. That's how this is written here. You want your base to be the same as your argument. So then you can solve, okay? Let's do some examples. Log base of 2 of 16 is equal to, so let's figure that out for a second. We want to change the argument so that it's the same base. And remember, the argument, and I'll circle it, I'm going to circle it, so this is your argument. I want it to be the same as the base. Okay, so we're going to change this so that it's log base 2 of 2 to the power of 4. Because that's essentially the same. Okay? Now, based on our written form here, if we have it all the same, that means that your exponent should equal your answer, is what you're looking for. Okay? That's what we're looking for. So, in this case, because we have 2 is the argument and 2 is the base, we can then safely say the answer is 4 because that's our exponent, which means that must be our answer. Okay, let's try another one. Log base 2 of 1 over 4. Okay, so we want to change this 1 over 4 so that it's 2 to the power of something. Right, so we want our argument and our base to be the same. So we want log of 2, and in this case, it's going to be 2 to the power of negative 2. So the answer is going to be negative 2, okay? So if I was to write this log base 16 in another way, that's basically saying that log of 2 of 16 is equal to x. And I'm trying to solve what x is. That means 2 to the power of x must be equal to 16. Well, 2 to the power of x is equal to 2 to the power of 4, right? Because 16 and 4 is the same, that means that x must be 4. That's essentially what we did here for A. Okay, and the same thing, same steps go for B. So B is very similar as well. Okay, so that's just another way you can kind of see, oh, that's how it works. Oh, okay. All right, so we changed it back to exponential form and then said, oh, okay, because that's what we did. So step 1, right? So the first part is what we did. The second part is the second part that I showed you at the bottom here. Okay, so what I'll do is I will say this is the first part, and then we have our second part. Green. All right. Both ways work. Okay, I'm not saying that this is the right way or this is the wrong way. Both ways work. It's up to you. It's personal choice. All right. Let's try another example. So we have a log base of 3 to the log base 3 with the argument of the root of 3. We're trying to figure out what it equals. Okay, so we have log base 3. Well, the root of 3 as an exponent form is just 3 to the power of a half. And now, since these are equal, my answer must be 1 over 2. Because that's what the exponent is. Okay, let's move along to log base 3, and then you're multiplying with your argument being log base 2 of 8. Okay, so we're going to evaluate the inside log first, because we can rewrite this to being log base 2 of 2 to the power of 3. And now, since this is log base 2 with the argument 2 to the power of 3, my answer must be 3. So that means log base 3 of 3, right? Because that's what this part equals. This part, okay. Well, log base 3 of 3 is 1. because there should be an invisible 1 being raised as a power there. Okay? That's what that equals. And that's your answer. So that would be the answer. I'll put a box around that, and that's the answer. Okay? Where it's log base 2 with the argument of 32 is equal to x. It's going to be, well, if we change it to exponential form, it's 2 to the power of x is equal to 32. And we want to rewrite it so that both of them have the same basis. So this is kind of going back to the last lesson. So that we have 2 to the power of x is equal to 2 to the power of 5, which means that x must be equal to 5. Okay? So let's try the next one. Log base x of 125 is equal to 3. So that means we have, if we write it in exponential form, it's x to the power of 3 is equal to 125. Which means that x is equal to the cubed root of 125, which means that x must be 5. So again, if it's easier for you to write it in exponential form, yes, by all means, make sure you do so. 4 is equal to 2 to the power of 6. So notice that this is not an equation. So what we're going to do is we're going to create an equation from it. So we're going to say, let log base 4 of 2 to the power of 6 be equal to x, okay? Which means that 4 to the power of x must be equal to 2 to the power of 6, okay? Because now we switched it around, okay? And in that case now we have 2, we want to make sure that everything's in the same base. So that's 2 to the power of 2 to the power of x is equal to 2 to the power of 6, which means that 2x must be equal to 6, which means that x must be equal to 3. So in that case, log base 4 of 2 to the power of 6 must be equal to, okay? So again, we made this an equation so that we can figure out and solve for what x was. All right, let's try another example. So this one, we have 3 to the power of log base 3 of 2 is equal to x. So what we're going to do, make a little note for ourselves, and we're going to change this to a log. So change to log. All right. So if we change it to a log, that means log of 3 of x is equal to log base 3 of 2. Since we have the same base, so since we have the same thing, log base 3 on both sides, that must mean if we drop them, not cancel them, okay? We're not canceling anything. We're just saying that, oh, because they're the same, then we can logically say x must be 2. Because you have log base 3 and log base 3 on both sides, okay? And then you have one argument is x, where the other one is 2. Well, that must mean that x must be 2. Okay, for you as well. Note, you cannot have a log of 0 or negative argument. These cannot be solved, which means they're undefined. So let's do an example of that. We have log base of 4 with the argument of 0 is equal to x. Well, if we rewrite that as an exponential function, that's saying that 4 to the power of x must be equal to 0. And that you can't do. That you can't solve, which means there's no solution. And finally, the last one, well, we have log base of 4 with the argument of negative 2 is equal to x. So if we rewrite that as an exponential function, we get 4 to the power of x is equal to negative 2. Unfortunately, you can't have that. You can't actually figure that out. So, which means there is no solution, okay? The last bit we're going to do is we will do estimations to figure out what certain benchmarks are. So without using technologies, without using a calculator. So steps to estimating logarithmic functions using benchmarks. So if our value of our logarithmic function is not a whole number, we do not have a calculator. And we do not have a calculator. We can estimate the value using benchmarks. So it's kind of similar in how you first learned square roots, and you were kind of able to estimate where square roots are based on your benchmarks of your perfect squared numbers. Okay, so it's kind of that in that sense. Okay, so step 1, turn the given expression into an equation. So to introduce and define a variable. Step 2 is to write in exponential form. Step 3 is to determine the two closest powers, one below and one above. Step 4 is use these benchmarks to estimate a value. And step 5, when writing your answer, you may round it to one decimal value. Remember, this would not be a calculator question, so we do not need to estimate to 3 decimal places. But be sure you use an approximate approximately equal to sign, so it's an equal sign with a dot on top instead of just an equal sign. Okay, let's try an example. Okay, so without technology, estimate the values of the following. So log base 2 of 10, okay, is going to be equal to x. So we're going to try and use our benchmark to try and solve this, okay? So first let's change this so that it's in exponential form. So that means we have 2 to the power of x, okay, is going to be equal to 10. All right, so we have certain parts that we need to do. We can say that 2 to the power of 3, well, that's equal to 8. And then the next benchmark would be 2 to the power of 4, which is equal to 16. Okay, so it's going to be in between these two. So we can roughly say, because 10 is closer to 8 than it is to 16, so it's going to be less than 2.5, or sorry, less than 3.5. So let's say that it's approximately 2 to the power of, let's say 3.2 is approximately equal to 10, which means that log base 2 with the argument 10 is approximately equal to 3.2. Okay, let's try B. B, so that is log base 5 of 100. That's going to be equal to x. Okay, so that we have, let's change that so that's in exponential form. So 5 to the power of x is equal to 100. Okay, so we have 5 squared. Well, that's equal to 25. And 5 to the power of 3 is equal to 125. All right, so in between those two values is going to be 5 to the power of something, which gives you 100. Okay, so 100 is closer to 125 than it is to 25. So we can say that it's past 2.5. So let's say that it's, to one decimal place, 5 to the power of 2.8 is going to be approximately equal to 100, which means to answer our question, log base 5 with the argument of 100 is approximately equal to 2.8. Okay, and finally the last example, I do believe is the last example. It is. Last example, we have a log base 2 of 14. So okay, so that's going to be equal to x. So let's change it so that it's in exponential form. So we have 2 to the power of x is equal to 14. Okay, so again, using the same types of examples way before, we have 2 to the power of 3 is equal to 8, whereas 2 to the power of 4 is equal to 16. So it's going to be in between these two benchmark values. Okay, so again, 14 is closer to 16 than it is to 8. So we can say that it's going to be 2 to the power of 3.8. Okay, that's going to be approximately equal to 14. Which means that log base 2 of 14 is approximately equal to 3.8. Okay. All right, so there you have it. This is the lesson on introduction to exponential, or introduction to logarithmic functions. I hope you enjoyed it. Go through this with them, okay? But always, when it comes to math, keep calm and show your work.